make sure I'm recording because that's important. All right. First off, are there any questions from last week that anyone has? Feel free to unmute yourself if you guys want to ask.
Kind of go over the nominal and ordinal again.
Just going over how to distinguish between the two. Okay. So nominal data is when you have categories, right, that don't have a specific order in which they would fall under. That's different from ordinal data, where it might look like you have categories or some type of ranking system in which there is a specific order that the variables go in. Right, so if you have an example of grade levels, right, you know that first grade comes before second grade, comes before third grade, and then before fourth grade, right? We don't necessarily know the quantitative difference between those grade levels, but we know that there's an established order that they have to come in. We rarely work with ordinal data in this class, but the best way to think about it is it's some type of ranking system versus nominal data, which has categories. I don't know if that clarified anything. Cool. Okay. My favorite part of the week, my memes, gifs, and dad jokes. I actually had this dad joke shared in a research group. A ghost's favorite exercise, deadlifts. Anyways, I thought it was great. I don't know if this has happened to anybody yet. We're technically not required to have you turn on your cameras, but I thought it would be funny with the given situation that we've been in lately. And then my last one, I bleeped it just in case people aren't a fan of profanity. But it's like week 2 and I don't know, I feel it already. All right, hopefully those were good. I thought they were good. But what we're really here to talk about today is percentiles and measures of central tendency. This is split up into 2 different chapters. So percentiles is discussed in chapter 3 if you have the book. Measures of central tendency is in chapter 4. It's not a super lengthy lecture today, so I'm hoping we are within our time. But we're going to start with talk about percentiles. Okay, and I figured out how to see you guys, because that was one thing I kind of shot myself for last time, was not making sure that I was checking in with the participant stuff because I didn't have it up. So you'll have yes, no buttons, go slower, go faster if you find me boring, or any other responses that you might want to insert as we go, and I'll just try to keep a better eye on that as I go. Okay, any other questions before we get started?
Yes, hi. There was a question in quiz that you need to enter stuff in it. What was that? Sorry, I missed that. You have to enter your response,
Yeah, so it's a short answer response. And so the number of points that you can get for the quiz is 10. But that particular question is worth 2 points and I have to manually grade it. So whenever you guys see your exported quiz grade, the highest it'll show is 8 out of 10, but just know that question hasn't been graded yet. And then the one that I grade will be off of your highest attempt, so you'll still have your max points before those 2 points are added. Okay. Cool.
Okay. All right.
Awesome. Okay. So Let's play with these reaction buttons. Has anyone heard of a percentile before? Yes or no? See if it works. Let's see. One yes. One participant. Oh, so if you guys like open the participants tab as I'm sharing my screen, you should be able to add your responses. I just want to make sure it works, that I set it up right. Ooh, yay, more yeses. Okay, if you haven't heard of percentiles, totally fine, because we're going to talk about them right now. But a percentile is basically some point or position on a continuous scale of 100. Okay, so you can have a 0th percentile all the way up to a 100th percentile, but we don't go past 100 and we don't go below 0. Okay, but basically what we say is if someone lies at a certain percentile, they represent a fraction of the population that exists at a particular raw score within the distribution or below that point. Okay, and I'll give some more examples because this is the definition the book gives, and I feel like it needs a bit more elaboration through example. But what a percentile is what we recognize as a standard score. And there will be several different types of standard scores that we talk about today. Maybe not today. No, next week. We'll talk about more next week. But there is mention of some in your activity this week. So yeah, standard scores basically allow us to compare a lot of different information, right? Either comparing or evaluating raw scores that come from different populations or different samples, which is more so what our case would be in statistics, right? Because we're mostly concerned with evaluating samples. Or they can allow us to compare different units of measurements, okay? So in the idea of measurements, let's say, because I feel like that one's usually a little bit harder to grasp, right? We can either say we're assessing health status, and let's say we measured it in one sample using heart rate, and we measured it in a different sample using blood pressure, and a different sample using VO2 max. Okay, each of those might give some information to the health status of an individual or the overall average health status of a sample. But who's to say which one is better, right? So we could, I mean, you'd have to look into literature for that, but we could technically say, like, if someone's at the 50th percentile based on the measurements of heart rate versus the 60th percentile based on the measurements of blood pressure, versus the 42nd, that's a very arbitrary number, but they're at the 42nd percentile for VO2 max, right? We can compare different scores, but still have a general idea of where a person is within a distribution, right? Or at least on the basis of that particular health measurement. So that's one example, right? But basically what standard scores allow us to do, the analogy I like to use is comparing apples to oranges, right? Or relating two seemingly unrelated things, or some things that might share some common characteristic, right? By standardizing the way that we evaluate them. So percentiles is a way that we do this. And then there was this kid deciding which cookie he likes better. Anyways, he's comparing, which is basically what percentiles and standard scores do. Any questions on the definition of a percentile? Hand raises, yes, no's. All right. So with this, let's just do a basic example of how we would translate a percentile into verbiage, okay? We're gonna say that Bob can do 40 push-ups, okay? And we use percentiles to evaluate how good or bad 40 push-ups might be. And this is largely dependent on the sample that you're working with, right? Because it's 40 push-ups good or bad compared to what? Let's say that Bob is a bodybuilder, We could call him Bob the Builder. You can laugh at my bad joke. Anyways, if Bob is a bodybuilder, doing 40 push-ups might not be that impressive, right? So maybe in a distribution of data that we've collected on, push-ups that bodybuilders can do, he lands in the 30th percentile, which isn't that great, right? He's on the lower end of the spectrum. However, let's say Bob is a middle-aged man between the ages of 40 and 55 years old, right? Usually activity declines with age. It's not always intentional, but life gets in the way, right? So maybe 40 push-ups for a middle-aged guy is equivalent to a 94th percentile, in comparison to the rest of the people that fall in that category, okay? Well, when we read, so it depends on the context, right? On what the value of the actual percentile is. But when we read these percentiles, right, in the case of Bob, the bodybuilder, okay, we might say if he can perform 40 push-ups within that distribution, Bob has performed equal to or better than 30% of the sample or population that he's associated with, okay? So it's always equal to or worse than. And I'm saying worse than on purpose. We'll come back to it in a couple slides, right? If we were to express the same verbiage on Bob the middle-aged man, we would say that 40 push-ups within a given distribution of push-up data, right? We would say that Bob performed equal to or better than 94% of the people within the sample or the population from which he was drawn. Does that make sense? You guys can throw up yeses or nos. Maybe a go slower if you want me to repeat anything. I feel like the general concept of percentiles is pretty easy to grasp onto. It's when we start calculating where people get lost. So, not to scare you, but it's coming. Okay, so we can evaluate percentiles on a scale, right? What I'm looking at is this area here. Percentiles, you see the bottom is at 0, and the top would be at 100, sorry, 100, okay? And then 50%, or the 50th percentile, should relatively land somewhere near the middle of the distribution, granted that we have a normal distribution, okay? And we'll come back to the bell-shaped curve in a couple of weeks, because that's a very essential characteristic of our data that needs to be met in order to run statistical calculations. But this is just to give you an idea. If we had a distribution of people, right, 0th percentile, usually it would be very rare that someone would be that close to 0. Usually we would see someone closer to the area between 1 and 2 standard deviations from the mean. But if you're collecting somebody who's way out close to the 0th percentile, or way out close to the 100th percentile, it is very likely that that person is an outlier in your data set and is potentially one skewing your data, but also kind of hints to the fact that they might not be representative of your sample or your population. Paulo, you said you don't see them. What is them? Just to make sure it's not something on the PowerPoint.
It was from earlier, but it was the participation thing, but I already found it.
Got it. Okay, cool. Just making sure. All right. So from here, we have to look at how we calculate percentiles. And we'll go over one way this class. We'll go over another way next week, possibly the week after, okay? But this week is pretty basic math, so I'm hoping that it doesn't scare you guys too much, okay? So again, we're saying percentiles represent a percentage of values or observations that fall at or worse than a given point. Now, a lot of times people will interpret worse than as less than or equal to. That's not always the case. So I put that here because this is kind of what your mind jumps to, but in some cases, a worse score might be a higher number in the number scale. Okay, so just keep that in mind. You're at or worse than. Okay. Okay. So basically, you're just looking at. Oh, question?
Yeah, question. Worse than is more like a bad thing, considered as a bad thing, or in negative sense, like no, like if you have higher blood count, white blood cell count, so it can be worse than in
Correct.
that way.
Yeah, exactly. So if we were looking at a sample of white blood cell content in, let's say 500 people, right? And it's always up to you as the researcher to determine what is on the better end of the spectrum, which would be closer to the 100th percentile, versus what would be on the worst end of the spectrum, which is closer to the 0th percentile. So in the case if you have a higher white blood cell content in your blood, that probably means that's usually linked to leukemia, right?
Mm-hmm.
Yeah. So in that case, we would say that would be on the worst side, right?
Okay.
Or you could say, because it's less desirable, or just to play devil's advocate in my own argument, you could always, if you're equating the value of the percentile with content period, as in the amount of white blood cells within the blood, maybe a person's at, like a 95th percentile, indicating that they have a very high count compared to the rest of the individuals, right? Which could be an indicator that they have something major going on. So
And the sign
Mm-hmm.
sign you're going to be using is the same less than and equal to sign, or it will be like different sign for that one, or greater than and equal to sign.
So we're just looking at, let me stop sharing for a second. I invested in a whiteboard. Can you guys all see it? Oh my God, I just ran into something. Okay. So I think a picture might help a little bit better. So if we have, just making sure you guys can see. Okay. If we have some normal distribution, right? And let's say this is the mean in the center. All we're saying is that if this is on the 100 side and this is on the 0 side, let's say this is our worse or less desirable direction versus our better. I don't know if that's a great word to use, but on this end it would be more desirable, right? In the context of whatever our situation is. All we're saying is that, let's say someone lands here, their raw score, right, is at this point in the distribution. We would say this person performed at or better than anyone who falls to the left of them. So again, the context of what is worse and what is better is kind of up to you. And that's your responsibility as a researcher. If you're, putting this content in like a research designer, you're describing it in the results section, you have to make sure you operationally define what the context is that you're scoring people with. Hopefully that made more sense. You guys can see the picture okay? Or is the quality really bad?
Picture is fine, but there's a glare on your thing.
Yeah, and that's unfortunately the only outlet I have in this room for the light, so I'll just make note to draw closer to this side of the board.
Okay. That'd be good.
Okay, well hopefully that helped some of you. Okay, so again, the way that we read, right, an 85th percentile, we're just saying a raw score is better than 85% of the other raw scores, okay? And we can calculate percentiles for frequency distributions, which was our topic of last week, right? In order to calculate percentiles for frequency distributions, we need to know a few things. And this is largely based on the type of distribution we're working with, but in general, you want to know the raw score or the rank of the person that you're evaluating or trying to find a percentile for. And then you also need to know the total number of scores that were collected from the distribution that the original raw score came from. Okay, so typically we use these calculations when we want to know where a person lies in a given sample. Okay, when we want to calculate percentiles for where a person would lie in a population, we use a different method, and we'll come back to that in a couple of weeks. Okay, so these calculations are if you want to know exact percentile of a certain raw score in a sample. Okay. All right. So let's practice this a little bit. If let's say we have a simple frequency distribution, which this should look similar to you guys from the activity you did, right? So we have some ordered data. In this case, my highest jumps are at the top, my lowest jumps are at the bottom, okay? And we have a certain frequency or number of people who are able to reach that vertical jump height, right? Given the height that we have in this scale. So, what percentile would a vertical jump of 33 inches be? Okay. Do we have all of the information we need to calculate the percentile first? I'll ask that question. You guys can use the yes or no buttons. I don't want to call anyone out. Let me clear first. Okay. So just based on the vertical jump of 33 inches and the data that we have in the frequency distribution, do we have all of the information we need to calculate the percentile? I have some yeses. I have more yeses. Does anyone want to be a Debbie Downer and say no? No one wants to. Okay, so in order to answer this question, we have to look back at our formula, or we could go back to the previous slide, right? Again, we need to know score, rank, and the total number of our sample, or however many people we collected in our sample. Okay. Within this formula, we need a cumulative frequency. So technically, yes, we do have all of the information we need. We just have to make a couple more calculations before we actually make our percentile calculation. Okay. So a cumulative frequency, let me click forward, is when we look at how many people are at or worse than a particular data score. So this is where associating the better or worse terms, okay, to your scale of data is important, right? So in this case, you guys can answer, or someone can like pop out and unmute themselves. What would be better or worse? A vertical jump that is high or a vertical jump that is low?
A vertical jump that's high would be better.
Vertical jump that's high would be better, okay? So when we're calculating cumulative frequency, once we determine what the high end of our, or the better end of our spectrum is, and what the lower end is, we can start calculating cumulative frequency. And we always want to start at the lower end, right? Because cumulative frequency is basically going to tell us how many people scored at or worse than a given score in that distribution, okay? So we start, if we look at a vertical jump of 26 inches, right? We know the frequency at or worse than 26 is 3. So usually the cumulative frequency at the worst score in your spectrum is going to be the frequency of the worst grouping or score that you have listed, okay? From there, all we do is we add, right, this cumulative frequency plus the frequency of the next best score, and that'll give us the cumulative frequency at the score of 27 inches, okay, which would be 6, because we just do 3 plus 3, we get 6, okay? To calculate the cumulative frequency of people who had a vertical jump of 30 inches or worse, right, equal to or less than 30 in this case, we would add our cumulative frequency of 6 to the frequency of 6 at 30, and we would end up with a cumulative frequency of 12, right? So this indicates 12 people were able to jump 30 inches or lower. Does that make sense? Okay, so we can then keep going on this scale. So 12 plus 7 would be 19, plus 2 would be 21, plus 2 would be 23, plus 1 would be 24, plus 1 would be 25, okay? The number at the best end of your distribution should always be equivalent to the total number of people you have collected in your sample, okay? So in this case, N, right, or total number of scores would be 25, okay? So now we have all of the calculations we need in order to figure out what percentile a person with a jump of 33 inches would be at, okay? So to calculate this, all we do is we say cumulative frequency at a given score. So at 33, we have a cumulative frequency of 19, and we divide that by the total number of people in the sample, which is 25, okay? That would give us the 76th percentile if we're rounding to the nearest whole percentile, okay? Participant responses, did that make sense? Yes or no? Hello, whoever just entered. Yes, yes, yes. Okay, good. So does anybody want to take a stab at what a percentile would be for a vertical jump of 38 inches? You guys can pop it in the chat. Someone could speak it out. Rounding to the nearest whole percent. Let's see, chat says 92. If we have consensus for more people, you guys can put a yes from the participant section. Another 92, this is looking good, okay? So yes, the answer is, in fact, the 92nd percentile, okay? So this would mean, or in order to get this 92, right, we take cumulative frequency at 38 inches, which would be 23, divided by 25 times 100 to get the percent, right? And that would give us 92, okay? So this is calculating using a simple frequency distribution. Love this method, it's the easiest way, okay? We get a little bit more complex when we're looking at a grouped frequency distribution. As you can see, there's a lot more variables at play here, okay? And I give you guys some practice problems in the PowerPoint, so you can go back, work those out, and then I'll post the answers later in the week. But when we have a group frequency distribution, remember there's a lower bound and an upper bound to a given group, right? So within this formula, X still represents some raw score, okay, within the distribution, of course. L equals the lower limit of the interval that X belongs in. So if I told you someone had a vertical jump of 23.5 inches, the lower bound of the interval they belong in would be 20. Okay, if I had someone who had a vertical jump of 16.4 inches, right? The lower bound of the interval they belong in would be 15. Okay. I represents the interval size, and this can be easily calculated by taking the difference between two adjacent lower bound values or two adjacent upper bound values. Okay, I like to go with lower bound because usually those are nice whole numbers. Okay, so in this case, our interval size we could calculate by saying 15 minus 10, and that would tell us our interval size is 5 inches. Okay, the interval size when you're calculating percentiles for different raw scores never changes. It is a constant in this formula. Okay. F represents frequency, and this is specifically the frequency that occurs in the group that X lands in. So again, let's say my raw score is 16.4, okay? The frequency that we would use in the formula would be 12 because 16.4 lands in this grouping, okay? Now this is the one that trips most people up. C is the cumulative frequency of the interval, not necessarily smaller than the interval in question, but the interval that's worse than the interval in question. And I guess I should change that for future semesters. The verbiage isn't ideal, but the way that we would go about this is, let's say we're using 16.4, right? We know it belongs in this grouping. We already said in the previous slide, vertical jumps with smaller values in inches, right, are kind of the worst of the spectrum of vertical jumps based on the information that we have, right? So the cumulative frequency I would insert into my formula would be whatever the cumulative frequency is at the grouping worse than where 16.4 would land. Okay. So let's practice the cumulative frequency thing again. We say vertical jumps at a smaller number of inches are worse than vertical jumps at a higher number of inches. So we would want to start our cumulative frequency column where? At the top of the table or the bottom? Someone said top. You would be right, because we want to start cumulative frequency at the worst score or the worst grouping. Okay, so cumulative frequency in this first grouping would just be equal to the frequency that exists, right? So it would just be 5. Okay, we then add this cumulative frequency to the frequency of the next group to get 17, right? Plus 20, we would get 37. Plus 25, we would get 62. Plus 15, we would get 77. Plus 8, 85. Plus 5 more, and we find that our total sample size is 90. Okay? So, applying this information, right, to percentile questions, let's say we want to know the vertical jump of a person at 30 inches, okay, given this frequency distribution. So I'm going to stop sharing again. And we're going to write this out here. Okay. This is non-glary, yes? Just not where my body is. Great. Okay. So our percentile calculation says that we need to start with a raw score. Somebody shout out the raw score that we're interested in.
16.4.
For this particular example, so if you go to
Yes.
slide 14, might be different number for you guys. It should be 30, right? Percentile for a vertical jump at 30 inches. So 30 is our raw score, okay? And we're gonna subtract that from the lower bound at which 30 lies within. So what would that be? Someone can shout it out. Whoa, that's interesting, people. Is everyone else hearing that? I don't know. Anyways, 30 lies between 30 and 34.9. Would everyone agree with that? I'm just going to take that as a yes because I technically lost all of my participant views. So we would say 30 is the lower bound of the grouping at which 30 lies in. Okay? We would divide this then. My bracket needs to be bigger. We would divide this by the interval size. What do you guys think the interval size is? You can say it out loud or go in the chat.
5.
5, exactly, right? And we find that by taking, right, 2 adjacent lower bounds or 2 adjacent upper bounds and subtracting them, okay? So in our case, the interval size is 5. What would the frequency be, or F in this case? Frequency at the grouping that 30 is in?
15.
15, exactly. Okay, I really did not plan the spacing out right. But we would multiply by 15, and then we would add a cumulative frequency, which should be
77.
I'm glad you said that, and good try. Remember, it's cumulative frequency at the grouping worse than the group your raw score lands in.
Would it be 62?
Here we go. Okay, so we add 62. Again, I'm really sorry about the spacing. I wanted to write big. I went too big. All right. Okay, we divide all of this by
90?
90. Okay, so that's the total number of people that we have in our sample. Right? Now remember orders of operations, right? We would want to calculate this chunk first, and then the rest of the numerator, and then divide by 90. And then, of course, we can multiply by 100 to get our percentage, right? So what did you guys end up getting for that one? Anyone get a number? Something along the lines of perhaps 68.9 or the 69th percentile if you're rounding to the nearest whole percentile. Okay. Did the way that we went about putting together that formula make sense? You can put yes or no. Yes, cool. Okay, let's do one more example. I'm gonna.
Wait,
yeah.
I got a question.
Go for it.
So I'm still confused on how to find the sizes of the interval.
Got it. So if you look at all of the lower bounds in this area right here, okay, we can take any 2 adjacent ones, any ones that are right next to each other. So like I usually go with the first 2, and we just take the difference between those 2 numbers. So it would say 15 minus 10, and the interval size would be 5. Or we could say, what's 40 minus 35? Interval size is still 5. So it
Okay,
just,
I see.
yeah, it represents the unit at which we're grouping things by.
All right, thanks.
All right, so let's do the second example. I'm toggling between screens, so hopefully that worked. I don't know if you guys can see, this is Boo. He decided to join us today. Okay, so let's say we want to calculate the percentile now of somebody who has a jump of 22 inches. Okay, so our raw score would be 22. Okay, what would the lower bound be for this score? Someone shout it out.
20.
20, right? 22 lands between 20 to 24.9, right? So 20 would be our lower bound. What's our interval size?
5.
5, remember it's constant. Okay, times what's the frequency?
20.
20. Okay, frequency at the group at which 22 belongs to. And then we'll add a cumulative frequency of
17.
17, right? Cumulative frequency of the group worse than the one in question. Okay, and this is all divided by 90, right? Sample size hasn't changed. Okay, hopefully this is starting to make a little bit more sense. We'll stay out of the way so you guys can write. Again, sorry for the glare. I'm gonna mess with that to see if I can fix glare issues. But what you should have gotten for an answer, if you calculated it, of course, is 27.8 or the 28th percentile. Okay. All right. Clearly, I'm not doing so great on time. I kind of suck at this. But the rest of this is stuff that you guys have seen before. So the next slide has some practice problems. Again, kind of follow the same concept where we're looking at peak power output. So in order to find cumulative frequency, determine what would be a worse peak power versus a better peak power. Okay. And then you fill in your cumulative frequency column and then figure out what the percentile is at each of these given power outputs using this formula. Okay. Any questions on that part? All right. Cool stuff. Okay, so the last bit I'm going to skip to here is based on measures of central tendency. A lot of these you guys have actually heard of before, probably in elementary school or at some point in high school. Okay, measures of central tendency just basically tell us where the middle of a distribution is. Okay, or the characteristics of a set of data based on where the center of that distribution is. Okay. And there's three main measures that we use. The first one is the mode. So this is the value that occurs at the highest frequency, right, or occurs the most, which we can easily collect now from frequency distributions, since you're pros at that now. We can also look at the median, which will tell us the value that falls exactly in the middle of our data set when it's in a ranked order or listed from smallest value to highest value. And then we can calculate the mean, which is probably the most popular within statistical measurements, and we'll say why. But that's the average, right, of your data. So just to touch on these a little bit, again, the mode is the value that occurs most frequently, okay? Sometimes you can have bi or multimodal variables, right? And that's when you would have two high points in your frequency distribution. The pros to using a mode is it's really easy to determine, right? We can put together a frequency distribution pretty quickly and then just find what the highest frequency is, and then you're done, right? It's also a good quick estimate of the center of the group, and a fair description of central tendency when data is normally distributed. Now we say fair description because let's say we had a frequency distribution between 0 and 100, and our mode occurred at 98, or this raw score of 98, right? If we were from 0 to 100, we would assume that the majority of the middle of our data would land around 50, okay? So if we have a mode at 98, that doesn't really tell us where the actual center of the data distribution is, right? It just tells us that a high frequency occurred at an outlying area of our spectrum of scores, or at this outer area of our distribution, okay? So that's where we get our cons, right? It disregards extreme scores that might actually be outliers, okay, or not scores that aren't representative of your actual population. And the con is that it's also not a terminal statistic. Terminal statistics are information that can be used for further statistical calculations. So a mode does not fit this description. Once you have the mode, that's all you could do with it. You can't put it in other calculations past what it actually gives you, okay? So the kind of takeaway on when you would use a mode is if you just want a really rough estimate of central tendency and your data are relatively normally distributed, okay? A median is, again, the middle score, or the score associated with the 50th percentile of your data, ordered from smallest to highest numbers, right? Usually we use a method, we say if you have an odd number of scores, it's the median is exactly in the middle. If you have an even number of scores, you take the average of the two middle numbers, okay? Pros to using a median is it's appropriate for ordinal data since it's already ranked in an order, right? It's also good for highly skewed data because it only is concerned with the middle number in a distribution, not necessarily numbers that are on the outer ends of the distribution. Okay, so in that case, it's not affected by extreme scores in the calculation of the median. Okay, however, it is a limitation because it does disregard extreme scores, right? So we might know what the middle of the data is, but we don't know any other information about the rest of the data set, or that an extreme score even exists, okay? A median is also not a terminal statistic, okay? So that means we cannot use it in further statistical calculations. Okay, so we would want to use a median if we have an ordinal scale, again, some data that is ranked, right, from smallest to highest number. We would want to use it when the middle score, right, or the most typical score in the middle, okay, is needed. Okay, and then we would also use it if we have badly skewed data because it doesn't count that skewed data. Okay. Questions so far? Looking good. Okay. So the last measure of central tendency is our mean. This is probably the most widely used that we'll use in this class, or the most widely used measure that we'll use in this class. And it considers both the frequency, or the mode kind of concept of the data, as well as the quantity of scores. So how many are actually in the distribution, similar to how the median works, right? So it's kind of a nice in-between of the mode and median. It's most commonly used in statistics and is also the most sensitive measure of central tendency. And this is because we collect all of our scores, add them all together, right, and then divide them by the total number of scores. If we are adding all of our scores together, that means, let's say, we have a distribution of scores between 0 and 20, right? We would expect, if we're normally distributed, we would expect most of our scores to be around 10, right? That would be like around the 50th percentile middle of our distribution if we had a regular bell curve. So if we end up getting a score like 19, but the next lowest score from 19, let's say, is 12, right? That's kind of a big jump, and that extreme score in that particular distribution might skew the data, right? Because it's adding a higher value than where the majority of the scores actually lie, okay? But this is also, other than like sensitivity to outliers, it's also a good measurement to use because it does consider all aspects of the data. And it also provides a basis for further statistical calculations. So it does. The mean is a terminal statistic. Okay? Or sorry, it's not a terminal statistic. Oh my God, I'm going to post something about that because I just screwed myself over. Okay? Just to reiterate, I'm sorry. Terminal statistics are where you have no further calculations that can be made. Just to clarify, my apologies. Okay? Terminal statistic, no more calculations can be made. It's terminal, it's ended, that's it, right? A mean is not a terminal statistic, okay? So a mode or median are terminal statistics because they can't be used in any other calculations. A mean is not a terminal statistic because it cannot, or it doesn't stop there, right? It can be used more in your statistical calculations. Does that make sense? Yeses or nos? I'm so sorry. I got carried away with my words. Okay. I'm not getting objections from people, so I'm hoping that I clarified it well enough. Okay. Yes. Okay. And then means are also more appropriate for ratio and interval data, right? Because we don't need to rank them. And they're also not based on category, right? Because we can't take the mean of males versus females. We can take the mean number of how many females were in the whole sample of males and females, right? But that would be more of like a ratio score, okay? Anyways, those are the pros. The cons are that we do have, so sensitivity is both a pro and a con, right? Pro in the sense that it is sensitive to your entire data set, but a con is that if you have an outlier and you don't catch it, that could be bad for the rest of the calculations that you put that mean into, okay? So all in all, we would want to use a mean when we have a normal distribution of ratio or interval data, okay? When we need to know both frequency and the quantity of values within the data set, and if we need to calculate further statistical information, okay? So this is just an example of how we might calculate different values, okay? So if we put this data on a little spectrum here, right, we can see number of pull-ups or the actual values that people were able to attain are on the x-axis. Frequency is on the y, right? So people, 2 people were able to perform 1 pull-up. 5 people, right, were able to perform 2 pull-ups, okay? And so on and so forth all the way out here. So what we would do if we were ordering this, right, we could say the distribution goes 1, 1, and then 2, 2, 2, 2, 2. And then you would list 11 threes after that, and 9 fours after that, and so on and so forth, okay? So using that information, right, we could calculate the mode. Obviously, we can calculate the mode by looking either at the graph or at the frequency distribution table. Does anyone want to shout out what they think the mode is? Have I lost you guys? Ooh, in the chat. 3, exactly. The mode would be 3 because that is the most frequently appearing score, right? We can also see the mode is at the peak up here, okay? If we ordered everything like 2 1s followed by 5 2s followed by 11 3s, and we found whatever the middle number was in our distribution, our median would end up being 4. And you guys can double check that on your own if you want to look. Okay. And then if we calculated the mean, we would add up all of those instances of those data sets, right? So 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2, right? All the way down the line. And we would be able to calculate the mean, right, by taking the sum of all of the frequencies of these pull-ups, right, but take the frequency of the actual pull-up number. That's why I said 1 plus 1 plus 2 plus 2 plus 2 plus 2 plus 2, right? And then we would divide that by the total number of participants we had within this frequency distribution. And the mean should end up being 5.1. Okay. So just to give you a ballpark idea of where these values lie, in a normal distribution, the mean, the median, and the mode should be equal to each other in a perfectly normal distribution, okay? You can see in this instance, we have an outlier on this edge over here. So you can see how it skews the data, right? So this is kind of what we're going to mess with in a couple of weeks, and describing how skewness or outliers are going to affect these measures of central tendency. But in general, you can see if we kind of took this outlier away, that these measures of central tendency are relatively towards the actual peak or the middle of our distribution. And that's kind of the whole idea that you want to walk away with, okay? Did everyone kind of understand how I did the median and mean, or what I was talking about as far as the calculation and setting that up goes? Yeah, yes. Usually I get to write it on a board, or do it on Excel. Okay. Thank you for the 2 people who said yes. That's valuable feedback. Are there any other general questions on what we talked about today, either percentiles or measures of central tendency? All right, so you guys have activity 2 that's due next Monday, as well as quiz 2. Okay. Hopefully activity 1 and quiz 1 weren't too bad on your own. And those are due tonight by 11:59 if you have not submitted them yet. Just a reminder that the Dropbox for the activity will still be open until tomorrow at midnight, but you will get point deductions if you turn it in late. Okay. As always, feel free to email me questions. And if you guys are good to go, or don't have any further questions, you are free to exit. Thanks for tuning in.